Hey guys, so we talked about chords in our last little lesson, and we ended up looking at kind of how chords, some of the rules connected with chords. How if we have a 90-degree corner with a line starting or running through our middle of our circle, if it intersects at 90 degrees, it divides the chord into two equal segments. We also said that if we have a line dividing my chord into two equal segments, that it has to be a 90 degrees. So I know those terms kind of seem opposite, but I'm just looking at them from two different perspectives. So what ends up happening is we're actually going to do now a couple of things where we're actually going to look at lengths of a chord. So this would be an example of something that you might get, and it looks really complicated when I'm looking at the picture. I'm just going to read the example out loud so we can kind of get an idea of where things are. So point O is the center of the circle. Important thing to know. So if a line is touching that point O, it's running through the center of the circle, which kind of helps us decide about whether or not it's going to be dividing my chord. AB has a diameter length of 26. So here is A. Here, I'll highlight it actually for you. Here is A, and here is B, and that segment there is 26 centimeters long. Something that's telling you it's basically a line running from one edge of a circle to the other edge of the circle, passing through the middle. We actually have a name for a line that does that. We actually call that a diameter. So I'm just going to write, I'll try and squeak it in. That's our diameter. So if we have a diameter that's 26, that tells me something else. It tells me that my radius would be half my diameter. So that's information that I want to add here because that's going to be important. Half of 26 is 13 centimeters. So now I know my radius is 13 centimeters. I know my diameter is 26 centimeters. Okay, looking a little bit further. C to D is a chord that is 10 centimeters long. So that tells me, slightly different color here, that tells me from here to here, there we go, from here to here is 10 centimeters, okay? And it wants me to determine the length of the chord, okay? CD is a chord that is 10 centimeters from the center of the circle. Okay, there's the 10 centimeters. So red is what we want to find, and we'll look at this one more time. Sorry guys, I got a little mixed up there. This is 10 centimeters. If I actually could get my pen to work. This is 10 centimeters. We know our radius is 13 centimeters. So what I kind of want to do is I want to kind of ask myself, is there a way for me to actually draw a line segment here that I know how long it is that would make a right angled triangle? Because if I noticed here that there was a 90-degree sign, so if I drew a line actually down like this, I know how long that line is. That line is a radius, and we know our radius is 13 centimeters, so I know that's 13 centimeters. So now I have a scenario where I have a right angled triangle. We saw that with a circle. I have one edge is 10 centimeters, I have another edge that's 13 centimeters, and now the big thing that I have to decide is I have to decide where my hypotenuse is. So when I look at this, my 90 degree is in that corner, so I'm looking at opposite, and that means that 13 is my hypotenuse. So I'm going to get a scenario where I'm looking at c squared minus b squared is equal to my unknown. So I have a scenario like that. So c squared is 13 squared, b is 10 squared, a is that piece of my unknown. That's a squared. So when I do my math, 13 squared is 13 times 13, that's 169. 10 squared is 10 times 10, which is 100, and that's equal to a squared. And again, I'm working vertically. 169 take away 100 is 69. To get a alone, I'm going to take the square root of 69, and I'm going to get an approximation. It's 8.30-ish. Now, there's a whole bunch of numbers after that, but I'm going to stop it. It says to the nearest 10th, so I'm going to stop at the 10th, and I get 8.3 centimeters. Now, that is the length of this segment right here. That is not the length of chord CD. That is the length of C to E. So this represents C to E. That's what we solved. To get CD, well, we know that that's a 90 degree. I'm going to erase some of all the lines that I put on here now. We know a couple of things. We know this is a 90 degree right there. And if it's a 90 degree, we say that that's going to cut that chord into half. We solved that a perpendicular bisector. And we talked a whole bunch about that yesterday. That 90 degree cuts the chord in half. So therefore, to figure out how long chord C to D is, all I'm going to do, I'm going to take that 8.3 centimeters and I'm going to double it. 8.3 times 2 is 16.6 centimeters. So I was able to solve for the length of that. And what I did, again, just to review, I first off figured out that I had a radius. I drew a line from O to C that was my radius, that was 13 units long. I used the information given and discovered that that 13 was my hypotenuse, subtracted subtracted the 10 squared, the area for that 10 squared side length, from my 13 squared, got my 69. Square root 69 is equal to 8.3 multiplied by 2 because I have two line segments that are identical. So those are the kind of problems we're going to get. That's one example. Another example might look something like this, where I have a pipe. And inside the pipe, some water is sitting inside the pipe. And I want to figure out what is the deepest point of that water. That's kind of what this question's asking. Now, it gives me a whole bunch of information. A couple of things that we need to know is we need to know the line segment. So it tells us, I'm just going to highlight it here, it tells us that AB is 24 centimeters wide. So that means from A to B is 24 centimeters. Okay? It tells us our radius is 20, and it shows that in the picture as well. So those ideas can easily now be used to come up with a solution. Well, we know from O to D, we know OD is equal to my radius, because it's another part of my radius. OA is 20, so OD is radius. So that means it's 20 centimeters. So I know how long that is. That doesn't help me yet, but that's an important idea just to keep in my head. I also need to know a couple other things. If I know A to B is 24 centimeters, then I know this 90 degree tells me these guys are split in half. So this half must be half of 24. So if I take 24 and I divide it by 2, I get 12. So this unit here is 12 units long. Well, now all of a sudden I have a scenario where I have a couple of things. I have a hypotenuse, which is 20 because my 90 degree is here. I'm going to the opposite side. That's my hypotenuse. So now I got a scenario where I have 20 squared, and I'm going to take away 12 squared, and that's going to be my unknown, which basically is going to be O to D. Not O to C, O all the way to D. So 20 squared is 400. Take away 144 equals A squared. So we pull out our calculator and we quickly go 400, take away 144, and we get 256. I'm going to take the square root of that because I want to find out the square root of 256 will actually give me A, and so A is actually equal to 16 units. So now that tells me all the way, and I'm just going to erase again because my picture is getting kind of cluttered. That tells me all the way from here all the way down to there is 16 units. So knowing that's, all the way to here is 16 units, all the way to C, because that's where the 90 degree mark is 16 units. I know that this distance all the way from there all the way down is 20 units, because that's the same as my radius. So to figure out how deep it is, how long C to D is, all I'm doing is I'm taking my 20 units from my radius, subtracting those 16 units to leave me 4 units or 4 centimeters deep. So the water is 4 centimeters deep. So quick review again, I looked to try and see that right angle triangle. I found out that this is going to be half the length, so I figured out that that's 12 units long. I then used Pythagoras' theorem to figure out how long O to C was, which is 16. I recognized O to D is a radius, the same way O to A is a radius, so I simply knew it had to be 20. Whatever this difference is, I would get by subtracting. So 16 plus whatever that is has to equal 20, or 20 take away 16 will equal that unknown, which is what we did here. Hopefully this is sort of making sense. This is where the chords get a little bit trickier because you got to kind of think about drawing. Frequently you're thinking about making triangles and drawing what you need to draw to make it work. So if you have questions, obviously let me know. I'll give you some give you some work to work on and to practice and to try some of these problems. Good luck, guys.